I have my own way of explaining mixture problems that is quite different from how the books do things, and most of my students have found this very successful over the years. So I'm going to explain it here. When I think of mixture problems, I think of the old Dr. Jekyll and Mr. Hyde problems where you have these test tubes or flasks of these liquids that you're going to mix together. And on the left, these are the two things that we're combining, and on the right hand side we have our mixture. Now, the way I handle these is I label the amounts of each mixture along the bottom, and across the top I put prices or percents, the way things are given to me. Depends upon the problem. Let's take a first look at this approach. One fruit punch has a 40% fruit juice and another has a 70% fruit juice. Okay, I know what I'm mixing together, and so these are going to be my mixing bowls or my test tubes. Not that we're putting fruit juice into a test tube, but I have a 40% mixture and a 70% mixture. I'm going to choose to write it this way, just as I read it. I could also write 0.40 and 0.70, but I'm choosing not to. How much of the 40% should be mixed? How much? I don't know. That's the amount that is missing down below. With 10 gallons of a 70% mixture, that matches up right there, to create a fruit punch that's 45% fruit juice. There's the percentage of fruit in my mixture. Now, I don't have labeled down here on the bottom right the amount of liquid in my final concoction here, but I do know that I have X gallons and 10 gallons being combined together, so I will have X plus 10 down there on the bottom right. Notice how easy it was to label this setup. Now let's write our equation. To do this, we go top times bottom plus top times bottom equals top times bottom, or in this case 40x, that's top times bottom, plus 70 times 10, that's top times bottom, equals 45 times x plus 10, and that's top times bottom again. And on the right hand side we're going to do some distribution. That is our main equation. We have 40x plus 700 equals 45x plus 450. Now let's get all the x's to one side, and I'm going to choose this time to subtract 40x off of each side, just so that I can have a positive 5x on the right. And while I'm at it, I'm going to subtract off 450 so I can have all of the constants on the left hand side. This will give me 250 on the left is equal to 5x on the right, and dividing each side by 5 tells me that x is going to equal 50 gallons. And that is the solution we're looking for. How much of the 40% punch should be added? Let's do another problem very similar to this. How many ounces of water? Okay, here we go. Let's mix our two things together. How many ounces of water should be added to 20 ounces of an 8% solution? Well, here's my 20 ounces amount of an 8% solution. How much water? Well, there's no salt in plain water, so I'm going to put a 0% up at the top left. And we're making a 2% solution, and there will be x plus 20 ounces of that final mixture. And so there, very easily, once you understand the trick of no salt being in water using 0%, it's very easy to set this up, and we can go top times bottom plus top times bottom equals top times bottom. So we will have 0x, which you will know we are going to ignore, plus 8 times 20 is equal to 2 times x plus 20. Okay, let's do some distribution on the right hand side, and we will just get rid of this 0x term out on the front. This will give us 160 on the left is equal to 2x plus 40 on the right hand side. And we're going to subtract 40 on each side of the equation, and that will leave us with 120 is equal to 2x, and therefore x is going to equal 60 Ounces are the units this time, so 60 ounces is the solution we're looking for.